All right, so let's get cooking. Things, video. All right, so we've been kind of building our dungeon crawler, but while we're doing it, we're like I kind of reference, kind of hiding the dog's medicine in its food. So we're introducing object-oriented concepts as we're going around. And I think we started drawing something last time. Yeah, something like this. So we kind of want to start off creating this little experimental model where we create an instance of a room, an instance of another room, and we create an instance of a player. And now where we're at is we need to put that player into the room, whatever that means. All right. So as of right now, when we look at our classes as we've designed them, we said that a room has a name and it also knows about a player. A player has a name, but also knows about a room. So both of them are going to know about each other. I know that I'm in this room, and if we give human properties to the room we're currently in, it knows about me, is kind of what we're trying to portray here. So if we go back into the code here, we go into room, we look up at our um, fields, we see that we've represented this, that a room has a name and it also knows about a player, even though when we build a room, and this is kind of an important example, is notice that when we bring a room into existence, we're only giving it a name. A room is not born with a player in it. We could have made it born with a player in it, but we decided, you know what, I'm gonna effectively create an instance of a bunch of rooms, and then I'm going to start connecting to each other. We haven't even talked about that yet. And then I'm going to put a player into one of those rooms. And then when the player says, I want to move to another room, we'll remove them from the room they're currently in. We'll put them into the next room. So at any point in time, we're only going to have one player in existence and is only going to be in one room at a time. So we'll add the player to a room at a later date. So what we do is when we build our room, here's the constructor for room, we're only building it with a name. We're setting the field owned by this particular instance of room, that is this dot name, equal to whatever name was passed in. And then we're going ahead and just initializing our field for our player to null, even though its default value is already null. So I would say this code on line 9 isn't necessary, but I would probably always write it. Good rule of thumb for programmers is never rely on default values. If you want it to have nothing in it, put nothing in it, which sounds like a really weird sentence, but I think you know what I mean. The way we say nothing is null in um, Java and C Sharp and C++, except C++, it's null in all caps. In Python, it's none. We've seen that. In Objective-C, it's the word nil, N-I-L. So these are all synonyms. It means nothingness. Just as Python uses self to reference an object from within itself, Java uses this, C++ uses this, C Sharp uses this, Objective-C uses self, Swift uses self, Visual Basic used me, but that's a dead language now. So, but all these things mean the same stuff. So again, pushing this agenda forward that it doesn't matter what language it is. It's all got the same crap in it. All right, so when we first build our room, it's going to be born with a name, and then we'll set the player to nothing. Go ahead.
What if creating player, the player? Like, is that just, that's not a variable?
Well,
It's something else.
in here, it's not being created. All we're doing is we're creating a container to hold a player when a player is added. So it's kind of like buying a car, and a car has a passenger seat, but there isn't actually a passenger in it yet. We've built a seat. It's all ready for a passenger to go in there. This is all ready for a player to be added to the room. But until we actually go ahead and have somebody get into the car and sit in the passenger seat, we're actually not holding anything. It's just a placeholder.
But that folder, so like how we would create an object.
I don't know what you're asking there.
Well, like player one equals new player.
So here's this guy here. So we created our player here. We created our two rooms here. So we can, if we think about this like sitting on the table here, we have two little objects over here that are rooms. We have one object here that's a player. So those are kind of our puzzle pieces that we have laying around that you can almost think of it as like we're in a play. These are our actors, and we're going to put them into motion as we play out our dungeon crawler. And main is our conductor that says this is what our scene should do, our scene in the movie should do. All right, so we built our two rooms. We proved that they're built by calling the display method on each of them that we wrote, and all the display method does is it spits out the word room followed by the name of the room, R1, R2, as we have it right now. Then we have our player, and then we proved that we had a player by calling his display method, which we also wrote. And this is where we were talking about scoping rules last time. So the code we have in here right now currently isn't what we actually want. We were talking about whether or not we had to say this dot name or we could just say name. And we talked about scoping rules. So rule of thumb, whenever you're referencing one of the fields, always put this dot in front of it, even if you didn't have to. It'll never be wrong. If you're talking about a field and you say this dot, the field name, it will never be wrong. If you don't put this dot in there and you missed a variable that had the same name, you might mess up, might be working with a variable with the same name but holding a different value. So we'll go ahead and take out that little test thing we had in there. And so now when we call display on a player, it's going to print out the word player followed by whatever that player's name is, which in this case I think was Mike. So we should get R1, we should get room R1, room R2, and then player Mike is going to be the output of our program right now. All right. So now let's put these things together. All right. We're going to start off by updating our display for our room. Because when we tell a room to display itself, it's not only going to display its name, it's also going to display, if it has one, the player that's in the room, right? So we want the display method to conditionally, for a room, display the name of the player that's in the room. So how do I ask, is there a player in this room? How do we ask questions in any programming language? If statements. So what would the Boolean expression be to say, is there a player currently in this room? How do we ask that question? Go ahead. Room.how, we're just making stuff up now? Here's our whole room code right here.
Java had something that says dot has.
Well, we have a dot equals for strings, but we don't need that in this case. So, okay, so we first of all, we have a variable here, a field called the player. And that guy's gonna hold our player if there is one. And we know by default it's equal to null. So that means if it's not equal to null, somebody's been put in this room. So we can ask the question like, if this dot, the player, we're talking about a field, we'll always put this dot in front of it. If that guy is not equal to null, which means it has something in it. If you are a older C or C++ programmer, you look at code online sometimes, this will also actually work. This dot the player, it checks to see if it's a thing. This basically says, is the player something? That's what this if statement asks. Super common, you'll see it in books and stuff, but I would say it's not a very good rule, but not a good programming practice. Huh? I mean, basically it works in all languages. I'm pretty sure every modern language will allow you to ask if just some object, and it'll just do the Boolean expression based on, does this have a memory address or not? Go ahead. Well, I don't think it's actually defaulting to true. I think it's boiling down to true because the question, it's when we just put in this, like I have it written right now, the question it's actually asking behind the scenes is this guy, does he have a memory address in him? And if there's a memory address in that variable, then it boils down to true, as opposed to like it just being true by default. And unless we do something to change it, it just stays true. So a real question is being asked here, but because it doesn't spell it out, it's definitely not good for beginning programmers, but I would even say for advanced programmers, just say what you mean. Don't rely on tricks and stuff built into the language.
I don't think that works in Java.
Which?
That having stuff later.
It's possible it doesn't. We'll try it.
Well, they give me an error when I tried it. That's
Okay,
why I
well,
never done it.
all right, well, I'll try it again in a second. Remember, you hate Java, so it's probable that you've screwed something up.
This is why I hate it. I can't do that.
But you might be right. You might be right. All right. So in any case, we're going to ask the question, if our field, the player, is not equal to null, that means there's something that's been put in there because we originally set it to null. So if it's not equal to null, then maybe we do something like system.out.println. Also here, this dot the player. Yeah, we'll use this as an example. Dot name. All right. So let's go ahead and see this work first. I want to come back to this code right here eventually, because we have written our code in such a way that allows this when commonly in languages like C#, Java, Swift, you wouldn't write it this way because you would have made these fields private, which means that you can't access a private field from player from within a class that isn't player. But since we didn't make them private, we can just directly access fields, no harm, no foul. Good.
What's the difference between calling this dot the player and then adding on that dot name at the end?
Well, the dot name says, give me this player's name. A player has a field called name. So when we say this dot player, we're talking about this particular instance of player. Then when we say dot name, we say we want this particular instance of player's name, the value that's stored in its field called name. And we know this is a field because it doesn't have parentheses. It's not the name of the class. So a variable.
But like, wouldn't the name already be included with this dot the player?
This dot the player is an object. So that would be a memory address by default. This is that whole two-string thing behind the scenes. All right, so we're only going to print out this line if there's actually a player in the room. All right, so it's conditionally going to display this line. We go back to driver here and we see we created our rooms. We call our room, tell our rooms to display them themselves. We have not put a player into that room at this point. So we don't expect either of these to have that extra line in there. So we'll run this again. We'll see it doesn't have that line in it. Oh, this dot. When did I write that? Is this a delete thing somewhere? Or, oh, thank you. All right. So neither of them got into that if statement because we haven't put a player in there. So now we need to teach our rooms how to have a player added to it. So we're going to build in a method into our room so that we can tell a room, hey, I want to add a player to you. So we'll go into room and let's go ahead and put this in our documentation out here. We'll have a function called add player that by its name probably adds a player to the room, right? So we'll go into our room class. We're going to add another function. And when we add a player to the room, the intention is we're going to take in a player and we're going to set our player field, the player field, equal to whatever player was passed in. There's not going to be anything we're returning. We're just doing something. They're handing me a player. I'm telling the room about the player, and then we're done, right? So our return type will be void. We're not going to spit anything back out. We just completed a task. And we're going to call this guy add player. We'll take in a player. I'm going to take in the player as the name since I like naming that guy that. So there isn't a great reason for me to have a different variable name here than I have as a field. It also forces us to use the this dot thing. So what we'll do is we're going to say this dot the player is equal to the player. Remember, variables resolve to their most local definition. So the most local definition of the player right here is the parameter that was passed into this function. But this guy right here, we have bypassed that and said, I'm talking about this dot player. I'm talking about the field here. Don't even try to look locally. I'm talking about that guy. Go ahead. Say this again. So like if you wanted to return the player afterwards, for example, well, if you wanted to return the player, then your return type would be player. You know, that's the type of object we'd be spitting back out. All right, so we're going to return nothing. We're just going to set the player. You know, if we wanted to give a little output, we could say, you know, player has been set or something like that. Good.
Does using this, does it make the program run slightly faster because it's not searching locally?
The short answer is probably. The longer answer is it really depends on the compiler. So it definitely doesn't make it run slower. But it's possible if you have a very fancy compiler, now they're integrating AI and stuff like that into these compilers, that it might go and explore what's going on. And if it notices that there isn't a local variable there, it might arbitrarily add this dot to it behind the scenes, even though you didn't write it. So you might get the speed anyways, but you're at least in control of that decision if you write it. Go ahead.
On line 6, what is the return type of room? Is it room?
Nothing.
Nothing.
What kind of animal is this? Cat, dog, or constructor? Constructor. What values do constructors return every single time? Constructors always come after the new keyword. So, which is our real estate agent for going and getting memory. So when we build an object, if we were to print out R1 after we built R1, we'd see a memory address. If we were printing out R2, so here, if I just do a system.out.println R1, like that, we're printing out the exact value that R1 holds, whatever that is. And right now, because we didn't overwrite the toString method, right now it's going to look like a memory address thingy. So constructors always return that kind of value. Therefore, it's kind of a waste of time for us to have to specify that, since they always do that. So Java says your constructor must be the same name as your class name. Your class name must be the same name as your file name. Those things have to be the same. So right off the bat, we know that this guy is a constructor because it has the same name. But we can also tell it's a constructor because it doesn't have a return type. Void is a return type. Void means it's not returning anything. In this case, it does return something. We just aren't the ones who have to say it. It's happening. Good.
What parameter add player,
So we're going to see me use it here in a second. So hold on that. Was there any other questions on what we have at this point? Okay. So let me take this line out here. All right. So we have our two rooms. We have displayed the rooms. We displayed the player. We know all our little puzzle pieces exist here. Okay. We haven't had them interact with each other yet, but we've built our toys. All right. So now what we want to do is let's go ahead and maybe add our player to R1, the first room. So we see inside of room, we've now written a function called add player. It doesn't return anything, but it requires that I hand it a player, some player. So what I'm going to do is I'm going to say R1, call your add player function, and go ahead and add P1 to that. P1 is a player. So we're going to pass P1 here as the input to add player. Add player expects us to send it an input of type player. What are we going to do with that? We're going to set our field called the player equal to whatever was passed in. And now, after we've done that line, if we call that room's display function again, when we get to this if statement, is the player now equal to something other than null? Because we've put a player in there. So if I go back to driver now, and I just repeat R1.display, we'll now see that it gets inside that if statement and displays the name of that player. Could not find symbol who? R1 method add player, variable R1 type room. Here's my room. Here's my, oh, I had it as a lowercase p there. Java is case sensitive. I typically naming conventions for functions uses something called camel case. Starts with a lowercase letter, and then each syllable you throw in an uppercase letter just so it kind of reads like something. Purely naming convention, not required.
So
So now you see the second time we call display, it says here's the room, but it also says Mike is here. It's now noticed that a player's in that room. But if we throw R2.display in there again, it'll still only show the room because there isn't a player in that room. So R1 has Mike in it, but R2 doesn't have anybody in. All right, go ahead.
could we possibly, like, if we wanted to make things simpler, put the if statement inside of the add player?
How would that make things simpler? Well, first of all, what are you trying to accomplish by putting the if statement inside of add player?
That once I create a player and I press like I put it to where it says add player, it automatically prints this player's been added to, I guess.
No, we can certainly do that. So perhaps if we kind of play it out as our dungeon crawler, we might do something like that. If we're inside this function, we know for a fact that a player has been added to this room. We don't have to ask any questions, right? So we could say something like system.out.println the player. Actually, whether we say the player or this dot player, it's the same thing now since we set them equal to each other in the previous line, but I'll say this dot player. This dot the player dot name has walked into the room. Something like that. So just giving us a little feedback. We're not returning that value, we're just displaying it. Giving us a little feedback that something has just occurred in our game. Mike walked into the room if somebody else was already in that room. We don't support multiple players at this point, but if our game did, we'd see that. So now when we add the player, it's going to give us that little bit of feedback. Here, Mike has walked into the room. Okay, so it's not a matter of simpler or not. It's like, what do you want your code to do and where is the right place to put it? You want to be notified once a player is actually added to a room, then you put the code inside of add room. If you only want to know about who's in that room next time you tell the room to display itself, put the code in there. In this case, we're kind of doing both. All right, so now we have two rooms and we have our player that we've just put into room R1. We'll call that the entrance to the dungeon. All right. Well, now if we're in this dungeon, so you're in this cave system or whatever, Dungeons and Dragons style. Okay, you're standing here, and maybe, you know, as we have it here, this room is to the north of this room. That's the way I've laid it out here. We visually have drawn our picture showing that R2 is north of R1. But if I have player one currently inside of R1, that's what we just did. When we said add player, we put P1 into R1. So he's now housed in there. The R1's the player knows about that guy. But if I want to give P1 the option to get to room 2, I need to give a mechanism for R1 to lead to R2. All right. So to start off with, let's not worry about the cardinal directions. Let's not worry like, there's obvious exits to the north, west, east, whatever. Right now, we're just going to say there's a line of rooms and there's a next room. Something like that, okay? So what we're going to do is we're going to add something to our room. Our room is now going to keep track of a next room. We'll put player there and the room over here. Okay, so a room is going to keep track of what room comes after them. Now, by default, when we bring a room into existence, it's probably not going to have a next room yet. We're going to kind of build all our Legos and then we'll start snapping them together. That's kind of how we'll pull this off. So we'll do that example. Go ahead.
What if there's multiple? Go to.
We're going to have that because we're going to say there's an exit to the north and an exit to the west. We'll eventually do multiple, we'll put an array or something, but let's just make the simple version of it first. All right, so we're going to go back to our room and we're going to ask our rooms to be able to remember an additional thing. So a room also is going to know about another room, the next room, or whatever we want to call it. And when a room is first born, the next room is not going to be equal to anything. So because its default value will be null, but because I've suggested never rely on default values, we're going to go ahead and set it to null. Good.
Room is the passenger seat, and the next room is the passenger.
Yeah, I mean, I see how you're connected to my metaphor.
I'm just,
Yeah, so if you want to use that, a room has multiple extra seats that are capable of holding. One is capable of holding a player, the other one's capable of holding another room. Room is a car, and now you have a car that can, I guess, potentially hold another car. The pointer to that other car, but yeah, but right now they're going to be empty. So it's this dot, the next room is also equal to null. So when a room first comes into existence, it has a name, it has the capability of holding a player, it has the capability of holding a next room, but those aren't there yet. Good.
Why would we want the type to be, room rather than just like string the next room?
Well, because if I go here, I have my two rooms and I want to be able to go from room one, R1 to room R2. So the place I want to go to is not a string. The place I want to go to is a room, another actual room. If I walk from this room out that door, I'm going to end up in a hallway. We're going to call that another room. It's not a string out there. So you call it with the kind of animal you're working with. So in this case, we wanted to go to an actual room. I think you're going to see it work out here in a second. We're basically doing the same thing we just did for player. We gave the ability to add a player to a room. So we're also going to give an ability to add next room. And this guy will take in a room as an input. And we'll say this dot the next room equals the next room. All right. So now a room potentially can have a next room. So maybe what we do is we go back to a room's display and we add in another if statement. We say that conditionally, when a room is displaying itself, if there's a next room, we maybe put in a obvious exits, the name of the next room, something like that. So very similar to what we did for our player. We'll put in a separate if statement. It's unrelated to the first one. We have, two different little hurdles that we can possibly go through. We could have a next room, but no player in there. It's possible. So we'll say if this dot, the next room is not equal to null, which the only way it could not be equal to null is if at some point we have called add next room on this guy and passed in a room that this room leads to. So if it's not equal to null, then maybe we say something like system.out.println obvious exits, this dot, the next room, dot name. So we'll just put in the name of that next room. Okay, so we're only conditionally doing that. When we ask a room, we're inside of room.java now, so the room class. When we ask a room to display itself, it will always do this line. But it's only going to conditionally do this and conditionally do this. So if we go back out to driver here, we see we built our rooms. We told them to display themselves. At this point in time, neither of those rooms has a player, and neither of those rooms has a next room. So all we should see up there is still just the name of the room. Then we create our player, and we tell the player to display itself. We haven't added anything to player yet, so it's going to do just the player's name because that's what we wrote in display. Then we go ahead and tell R1, go ahead and add P1 to you. So now we've put a player into R1. So now if we tell R1 to display itself again, we will get inside this if statement because there is a player in there now, right? But there still is not a next room. So when we display R1, we should see room R1, and then we should see also here Mike. But we will not see obvious exits because this guy doesn't have a next room at this point. All right, so that's this part right here. Now, if we go ahead and we say, let me just take out the R2.display for a moment. If we say R1.add next room, R2, that's what I called it, right? Add next room? Yeah, add next room. So add next room is the name of my function. It requires me to give it a room. And then what it does is it sets this particular room's next room equal to whatever room you gave it. So I want there to be a next room that goes from R1 to R2. So if I call R1.display now, it's going to get into both if statements. There is still a player in that room. And there also now is a next room. So it's also going to show me obvious exits. So here's room R1. Also here is Mike. Obvious exits are R2. So far, so good. Now, one thing I want you to kind of gather here. And first of all, just like I've said multiple times, I realize most of you can't just sit down and write this. My point of doing it this way is to show you it is possible. I promise you this is easy code. And in a semester or two, you'll also find it easy code. All right. So if you can follow what I'm writing right now, but you feel like, okay, I'd probably make a lot of errors, you're where you should be. Okay. It's going to take some time before you can just sit down and start writing something. But notice that even I am drawing pictures. So I'm kind of designing it and then fulfilling my design. I'm drawing out what I want. So I kind of have a plan. Now, at something this size right now, I wouldn't need to draw pictures for this, but I'm going to encourage you to draw pictures always for now until you start feeling like, okay, I'm wasting my time drawing pictures. For me, obviously, I'm in front of a classroom. I'm going to keep drawing a picture because even though I could juggle it in here, you're not inside my head. None of you want to be in here. So that would be its own little adventure. But I want you to see it's possible. I want you to see this really isn't difficult stuff. And I want you to make sure you're following what we're doing. So if you feel like, okay, I have no idea what that line of code does, that's where you want to start being concerned. What did you miss? Okay, because at this point, I'm using just simple if statements and stuff like that. I don't know if I've said this statement before, but I'll say it now. All hard programs are made up of a bunch of easy parts. If you looked at the source code of Windows 11 or the source code of Linux, what you would see in there, these are major operating systems, right? Zillions of lines of code, and I'm rounding down. You would see integers, chars, if statements, for loops, a majority of the code in there, you would be able to understand easily. just simple stuff, just like we're doing here. Every now and then you might get to a part where it's a little bit more complicated, like things like scheduling processes for the CPU, where, okay, now you have this processor with 8 cores in it, and we're trying to come up with a fancy schmancy way of how do I take advantage of my resources so I'm maximizing my CPU power and all that stuff. So things might get a little bit more sketch, but what you'll end up seeing is just kind of more complex Boolean expressions inside your if statements, or multiple tiers of checking, or kind of a multi-threading thing. And we'll look at multi-threads here pretty soon here, because we're going to want our program to feel like a living thing, right? We want to be sitting in our dungeon and us having an option presented in front of us, like, where do you want to go? North, south, whatever. And then for there to be a chance that a rat walks into the room. Well, if the program's waiting for us to give it an answer, give it some input, like, okay, I want to go to the north, that rat can't walk in unless we've created a situation where our program has two kind of independent lines running. We have the, hey, I'm controlling the monster program, and hey, I'm talking to the user program. And these two guys are connected, and we're going to learn how to do that when we turn this into multi-threaded. Also not hard, but sounds more difficult than it is. All right. So at this point, we're able to connect a room to another room, at least in principle. We haven't done the thing where a player can go to the next room yet. But at least R1 now knows about R2, and R1 also knows about the player. All right, so we kind of have all our pieces together. So if we're the player right now, and I'm standing inside of R1, R1 is at least advertising to me that there's a room over there. Okay, it hasn't given me the ability yet to choose to go that way, but I'm in the room. I see the exit, or I see the place I can go. Now we want to open this up some. All right, so what we're going to do is what we're building here, and we keep referencing, is a dungeon, right? So a dungeon is going to be a collection of rooms, and then in our case right now, a single player that's been added to the dungeon. So let's organize that. So we're going to add another class. And we're going to move a lot of the stuff we currently have in main into dungeon. Because really what we're doing in main now is kind of our sandbox for messing around with rooms and players, just to kind of make sure our objects are working. So let's kind of move that into our dungeon so that in main we can just say, create dungeon, poof, and then say dungeon.play or something like that, and that starts the game going, right? But creating the dungeon is going to generate the 2 rooms. It'll add the player to the first room and you know, all that stuff. So we're going to say a dungeon. Maybe a dungeon still has a name. You know, you got to call it something, the Dark Fortress or whatever. A dungeon is going to have a collection of rooms. A dungeon is probably also going to have a starting room. So maybe a dungeon independently knows about every single room that makes up that dungeon in case that is handy for us in the future. But it probably also knows, where does this dungeon start? Where's the first place in there? All right, because that first place in there is the when a player walks into the dungeon, that's the place that we'll put them, is in that that room. All right, so let's just start with this for right now, these 3 things. Keep it simple. You're noticing, even though we have 3 different classes here, we're kind of doing the same crap over and over again. All right, so we'll go in. We're going to create our class called Dungeons. So that'll be, that didn't work out well. All right, so we're going to call this dungeon.java with a capital D, because that's going to be the name of our class. Dungeon.java is going to be the name of the file. We're going to put in here a class called Dungeon. Then we're going to have a constructor for our class. So remember constructors, what's the return type for a constructor? Doesn't have one. What's my constructor going to be called? Dungeon. Same name as the class, same name as the file. So we're going to have dungeon with no return type. And we're going to actually go ahead and just say this guy will just take in a name. And we're going to go ahead and we're going to create some fields for our dungeon. In our design here, we decided the dungeon's going to know about a name. It's going to have a collection of rooms. And then it's going to have a starting room. All right, so I'm going to do a little bit of a hack here because I don't want to introduce something I don't want to introduce something new yet. So name is going to be easy. What kind of value do we need to hold a name? String. So we're going to have a string, and in Java, string is capital S. We'll call this guy name. We're also going to have a room that is the entrance to the dungeon. So that guy will be of type room, and we'll call that the entrance. Now let's just start off with those two things. I'm going to add something else here in a second. So in my constructor is only taking in the name of this dungeon. So I'll go ahead and say this dot name is equal to name. And then I'll say this dot the entrance is equal to null. When this dungeon is first born, there isn't an entrance. We're going to change that here in a second. All right. So now, before we go any further, let's go ahead and create our instance of dungeon. I'm just going to delete all this stuff here. We'll rewrite it, and we'll rewrite parts of it in the other thing. So inside of main, because all programs begin and end with main. Yeah, you'll see it again inside of our dungeon in a second. So inside main, all programs begin and end with main. We're going to have our dungeon, call that the dungeon, is equal to a new dungeon. So we're calling the constructor for dungeon. So we got to go back to our code and see what does my constructor expect me to send it. Here's my constructor for dungeon. It expects me to send it a string representing that dungeon's name. All right, what do you want to name our dungeon? Anybody have a good name for a dungeon? The donut? Lip, that's a stupid name for a dungeon, but we're going with it. That was a good catch. What did you even say?
The done.
The done?
Yeah.
It's like cute, you know?
Like D-O-N-E?
Like the dungeon.
Oh. Oh. Yeah, that was stupid. All right, let's call this
I'm just kidding, that is.
all right, we're just gonna go with the done so that when every time I see that, it'll remind me of this stupidity. All right, so we've created a dungeon,
Lippman is part two.
but I didn't come up with it.
Well, you wrote it down, we're gonna go.
Well, because I thought it was the stupidest choice, but no.
So that-
Lit done.
Stupidness combined.
All right, we'll just roll with this for now. We can always brainstorm and change the name later. It's just one line of code we can shift. All right, so we've created our dungeon, but right now all a dungeon is a name, and technically it has the ability to hold an entrance, but there isn't an entrance there. All right, so what we're going to do here is we're going to go ahead and design our rooms just like we did before. So we're going to say room R1 is equal to new room. And we'll call this guy R1. We'll create our room R2. This is during the construction of a dungeon. All right, so if we're sitting here and we're saying, poof, dungeon come into existence. Part of the construction for this dungeon is going to be building the rooms that are part of the dungeon. Now we're going to be hard coding these rooms for right now, but before long, we're going to be representing our dungeon inside of a JSON file, which our constructor here can go ahead and say, you just tell it the name of the file to pull from, and it'll go and read in the specific dungeon you want it to build. But right now, we're just hard coding a couple of rooms. Go ahead.
class rather than like the driver class?
They were both hard coded before. They just at this point in time, every single dungeon we create will have the same kinds of rooms in them. They'll just all look the same.
But like not constructors, but like objects inside of our dungeon class.
Why do you think it might not be?
I don't know, I've always been taught to put it in main. So if I like put it in a separate class, it just.
Well, I mean, it effectively came from main. The only way we get here is if we have this line of code in main. All programs begin and end with main, and the only thing main says to do right now is create a dungeon. And creating a dungeon involves calling the dungeon constructor. That takes us right here.
The same thing.
The same stuff's happening. We're just encapsulating it inside of an object. Remember when we went back and we talked about the procedural versus object-oriented telephone? Okay. We just took our pile of wires and shoved it into a room object, or shoved it into a dungeon object. So we no longer see these rooms strewn about. All right. They're still there. All that same code is there. All those wires are still inside the telephone. We're just not seeing them anymore. So main looks a lot prettier. All right. So we'll say R2 for this guy. And then we're going to go ahead and we're just going to add next room for, what did I call it? Add the next room or add next room here? Add next room. So a room knows how to have another room added to it. So we'll say R1, add next room, R2. So now R1 links to R2. And then we also want to go ahead and put our player into this room. So we're going to say player P1 is equal to a new player Mike. All right. And now at this point, this player's just sitting there doing nothing. Let's go ahead and add that player to room 1. All right. So we go and look at room again. Room has a function called add player that expects me to give it a player. So inside of dungeon, I'll say R1, call your add player function and pass in the player that I want to add to R1. Just put a little spacing in here for clarity. All right. So at this point, we have 2 rooms, R1, R2. R1 has set its next room to R2. And R1 has also added P1 into it as the player that's now put into our dungeon. All right. And actually, you know what? I'm going to take that out for right now. This would have worked, but we're going to do it a different way. We're going to bring the dungeon into existence and then have our player walk into the dungeon, which is how it might work in real life, right? All right. So right now R1 is linked to R2 through this next room thing. Now we're going to go ahead and say, you know what? The entrance of this dungeon is R1. We're just going to arbitrarily say this. There's 2 rooms in the dungeon and the entrance is R1. All right. So that's what our constructor is going to do for right now. We might add some additional fields as we go. So now we need to have the ability to add a player to our dungeon. So we're going to go ahead and create a function. It'll return nothing. We'll call this guy here. Why don't we call this enter dungeon? And this will take a player as a parameter. And we'll say this dot. Now, when a player enters the dungeon, where are they going to go? To what's another way of saying R1 on line 20 here? Do I have access to R1 here on line 20? Where was R1 born? In the constructor. And he died. Mostly died in the constructor. He had a pointer count of 1 after line 10. So there was 1 pointer pointing to where R1 was up in memory. But then we got a second pointer count. This variable called this dot the entrance also points to where R1 is. And when that constructor ended, the original R1 disappeared. That variable got reclaimed, garbage collected. But we still have this other variable pointing to it called the entrance. Do we have access to the entrance here inside of Enter Dungeon? Yeah, because the entrance is a field. It's a global variable inside of the class dungeon. And I have two modules, if you will, sitting inside of my dungeon. Right now, we're in one of those modules. He has access to the fields. So we'll say this dot, the entrance, which is a room. And what do we want to do with that room? We want to add this player to it. Dot add player. And we'll go ahead and put P in there. Now, I didn't just make up this add player thing. We wrote that. If we go back and look at our room, we see that we invented this add player function. And now we're just calling it. So this is all our design. This isn't stuff built into the language. You know, so we want something to exist. If it doesn't already exist, we have to go make it exist. All right, so Enter Dungeon is going to have the player named to what? He'll already have player. He'll already have a name rather. So let's use this. So we've added this ability. This player came from somewhere. Somebody's going to call this function, and someone's going to hand us a player. Presumably, they've built a player properly and given him a name and all that stuff, but that all happens somewhere else. All right, so we'll go out to driver here, and we're going to say, okay, well, we have a dungeon. Let's go ahead and create our player. All right, so we have two things inside of main, the dungeon and the player. And now we want the player to enter the dungeon. The dungeon dot, what did I call it? Enter dungeon. I'm not sure I love that name, but we're going to leave it. And the enter dungeon function, if I look in dungeon here, enter dungeon returns nothing, but he needs me to give him a player in order to work. I happen to have a player right here that I've named Mike. So I'll go ahead and send P1 in there. So now we've added P1 to the entrance, well, to our dungeon. We've told him to enter the dungeon, and enter the dungeon does whatever it means to add a player to the dungeon. All right. Behind the scenes, the user doesn't have to see it, but what does enter dungeon do? It puts that player in whatever room is the entrance to this dungeon, which relies on us to making sure that we had set the entrance to some value. Because if we had forgotten to do that, we would have a problem. So let me go ahead and quickly write a little display method for our dungeon. So a dungeon can display itself. And what a dungeon is going to show is its starting room. We're going to ask its starting room to display for right now. So we'll say this dot, the entrance dot display. The entrance is of type room. We built it right here. So that variable is a room. Rooms have a function called display that takes no parameters and returns no value and prints some stuff to the screen. That's what it does. All right, so for enter dungeon works that way. For display, we'll just tell the entrance to this dungeon to display itself. When we go, well, let's see it work, and then I'm going to walk back through it. All right, so out here in main, created our dungeon, created our player, put the player into the dungeon. Then we're going to ask the dungeon to display itself. And behind the scenes, what does display for dungeon do? It calls the entrance to the dungeon, which is a room. It calls his display method. which is rooms display method, which is this guy right here. Notice that conditionally, if there's a player in the room, it'll display something. And if there's a next room, it'll display something. Well, let's try to predict what this guy's going to do before we hit play. When we build a dungeon, this is all the stuff that happens when we build the dungeon. We set the dungeon's name. We create a couple of rooms, and in this case, all of our dungeons are identical dungeons. We'll change that in the future, but we've built 2 rooms. We've added one of the rooms as the next room to the first room. And then we've let the first room become the entrance to this dungeon. All right. So the entrance to this dungeon is the same room as R1. Good with that? R1 currently has a player in it. How? By way of calling enter dungeon that added the player to whatever the entrance was to this dungeon. And the entrance to this dungeon is R1 that we put in the constructor. So there is a player in the room. Secondarily, is there a next room? Yes, there is. In the constructor, we added R2 as the next room to R1, and R1 is the entrance to our dungeon that we set right here on line 15. So when we tell the entrance, which is R1, to display itself, it's going to display its name. It's going to ask the question, is there a player in here? The answer is yes. So it'll display the also here line. And then it's going to say, is there a next room? The answer is yes. R2 is the next room. So it's going to display that line as well. All 3 things will get displayed. All right. So we'll go ahead and run that. So remember, this line is when we added the player to the room. She wanted to have a little commentary that, let us know that somebody just walked into the room. So Mike has walked into the room, the entrance to the dungeon in this case. The room we're in has a name of R1. Also here is us. We might, once we start building this, we might choose not to show us because we can just assume that, well, I'm seeing all this stuff about the room, so maybe I don't need to know that I'm also here. But for right now, we only have 1 player. This is mine. And we see that there's some obvious exits. All right. So now we've walked into the dungeon. We're standing here. We see that we're here. The dungeon has let us know that it knows that we're here. We're going to have to modify some stuff there as we think about moving to a room. So there's our R2. R2 is through that guy, through that door. So I'm in the room. I want to be able to enter that room. I want to have the option to do that. So for starters, our program has to become interactive. Somewhere in there, it's going to have to say, hey, what do you want to do now? What are the lists of commands that we want to support? Okay, maybe we want to support a player typing in look. And what does look do? Maybe ask the current room to display itself. Maybe we want to support the command either move R1, or maybe we just give it a name. If we say R1, it'll go through an exit named R1. So for our dungeon, we're going to write a function maybe called start. We build our dungeon, we added the player to it. Now we're going to tell our dungeon to go ahead and start. That's going to turn the power switch on, if you will, which is going to put us into this loop of asking the player, what do you want to do? What do you want to do? What do you want to do? That kind of stuff. All right, so this will be void. We'll call it start. Doesn't need any parameters to work. All this guy is going to do is put us in an infinite loop that just keeps asking the player, what do you want to do? So we'll say while true. System.out.print. What do you want to do? A little space here. Print something out and doesn't press enter. So it keeps it on the same line. All right. So now That's all Start's going to do right this second. I'm not asking them anything. Well, I'm pretending to ask them something, but I'm not actually waiting for their response. I've asked a question. I'm just going to move on and ask the question again infinitely. All right. So we go back to driver. After we've loaded our dungeon, and I'm going to change this here in a second, but we're going to go ahead and say the dungeon dot start. So inside of dungeon, we've written a method here called start that returns nothing and requires us to give it nothing to work. And all this guy does is loops forever and just prints something to the screen forever. So we will be killing this program once it starts before it gets too out of hand. Because right now, we're just going to have a wall of what do you want to do? What do you want to do? What do you want to do? All right. So we probably want to actually let the user respond. Okay. So this gets us on into a concept called blocking code. This is a line of code that blocks the rest of the program from continuing. Typically, while waiting for user input, but could also be waiting on data from an external source or similar. So maybe your code is plugged into ChatGPT and you send a prompt to ChatGPT, and maybe it's going to take 5 or 6 seconds for that prompt to come back, whatever. And if you don't do anything special, your program will pause for that 4 or 5 seconds while it waits for that response. And then it'll do something with that response. But until it gets its answer, it can't do anything. It's kind of stuck. Our solution to get past that in situations where we want to, and I'm not going to talk about it too much right now, but foreshadowing is that will be threads. We'll create a thread to do this stuff so that other things can be happening. All right, so we're going to go ahead and insert some blocking code. And this is going to be code that basically says, it's going to read in something from the user. You've got it in Python. Was it input? I think was the function in Python. Here, we're going to use a function called, we're going to use a class called scanner. So I'll go into dungeon. We'll go ahead inside of start. We're going to create a scanner. I'll call this guy input. Now, when you build a scanner, it requires you to give it an input stream. We can look at the documentation for this real quick. Scanner Java. So there's going to be multiple constructors for this guy, but we're going to see one of them is it takes in an input stream. Come on, you can do it. So you can read it from a file, blah, blah, blah. But here's this thing called an input stream. So that is, you're telling the scanner what source will you be reading stuff in from. And what we want to tell it is, oh, I want you to read in from my keyboard. We're the person typing stuff in. And in most operating systems and most programming languages, the keyboard is called system.in. Okay. It's the main input stream, system.in. There's usually a system.in, a system.error, ERR, which are both input streams, but it allows you to separate errors from what the users see for log files. When you have programs that have errors in them and you want your operating system to kind of keep track of those inside of a log file. So when something crashes, you can go look at the logs and say what happened. You probably only want to see error stuff in there, not all the user input that's occurred while you're using your computer. So it does separate those two. And then there's a third one, which is called system.out, the monitor. All right. Those are the things built into most operating systems. Oh, I'm not going there. What am I doing? I'm lost. All right. So while we're building our scanner, we're going to say, I want you to read stuff in from the keyboard. At some point, we'll break all this down, but the lesson right now is not scanner. We're just This is how you read stuff in for right now. All right. So we're saying, what do you want to do? So we're going to say, no, scanner's in, it used to be in util. I think it's in just normal Java. It'll scream at us here in a second if we do, but I don't believe we have to. But we'll find out. All right, so we're gonna have a, we'll call this guy input line. And we're gonna set this equal to input dot next line. We went into the documentation, we'll see that there's a whole bunch of functions built into scanner, like reading in the next int, reading in the next double. We just want to keep reading in strings from our user and doing something with them. So there's this thing called next line, which sits there and blocks the rest of our program until our user types something in and presses enter. All right, so just putting that one thing in here. We'll go ahead, go back out here to driver. Oh, you were right. And actually, we could have tested that. What did I do down here? This will tell us at the very top, where does this guy live? And he lives in java.util still. I thought he had moved out of there. But of course, I don't make mistakes, so I was testing you. You passed. All right. So I'm still waiting for me to introduce my first bug into a program. All right, so we're going to import java.util.scanner up here so we have access to that guy. Now, when we run this, it's now heard of him. All right, so now we don't have the wall of text going, because instead, even though we're inside of an infinite loop, we're showing us the current room, and then we're saying, what do you want to do? And now it's blocking the rest of the program. It's waiting for us to type something in. So I can type whatever I want in, because what it's doing is it's going to catch what I wrote in into that variable called, what I call it, input line or something like that. Yeah, I'm storing it inside of a variable called input line. And what am I doing with input line right now? I'm not doing anything with it. I'm just going to loop back up and ask them again, over and over and over and over again. But at least we're seeing how blocking is working. All right, so if I go down and I press enter there, it's just going to ask me again. I can type in whatever I want. It's just going to keep asking me, asking me, asking me, asking me. I'm not doing anything with that code. All right, so now, I'm going to go ahead and stop. I'm going to throw a question in here real quick, just so you have a kind of a starting point for your homework. So we're going to say if input line dot equals, I'll do ignore case, so they can type it with uppercase or whatever if they want, exit. All right, so now if what they typed in is the word exit in all caps or however they want to write it, then we'll say goodbye and we'll break out of this infinite loop. So if I run it right now, as long as I type in things that is not exit, it's going to keep running. But as soon as I type in exit, it's going to tell me goodbye and the program will exit. All right. So your homework is I'm going to give you this as a starting point, is going to be create the ability for the player to type in R1, which is the next room, or I'm sorry, R2, and it will take them out of the current room and put them into the next room and then show the player that next room. All right. Easy thing to solve. It's probably going to take several of you a long time. You might not solve it. It's okay. I want you to wrestle with it. If you've thrown more than 3 hours at it and your eyes start to bleed, submit it. Tell me where you got stuck. That's fine. Then you'll come back to class. We'll see how it works. You're like, that was it. Blah blah blah. And we're done. So go ahead.
So you want us to, like, when we ask the user, what do you want to do? We have to put like a room in.
Yeah, you would, like right now when we run this, it shows us the details of the room that we're currently standing in. And it says there's an obvious exit to R2. So I want it to be, if we type in R2 and press enter, it takes us out of this room, puts us into R2, has R2 display itself. So we should see, Mike has walked into the room. Room's name is R2. Also, here is Mike. Obvious exits, probably nothing, because we don't have a way of going from R2 back to R1 yet. All right. And I'll put it into the homework, but just kind of one little step into our prompting. All right. Questions, comments, concerns, bribes? I got a bribe?
I'll do some of the assignments from yesterday.
Yeah. So I'll put up a thing. Maybe you didn't hear what I announced it, but I was having people take selfies by the TV. But if you were at the thing yesterday, I do have a picture of the entire room. So submit that, if you don't have a selfie of it, just say I was there, and I'll be able to confirm it from my picture of the whole room. So just don't lie and everything will be fine. But if you were there for the event, you'll get your extra credit. I'll put up an assignment for that.
Oh.
All right. All right. I will see everybody on Tuesday. We're meeting for a few minutes, right?
Yeah.
Sure. Sure.
I'm gonna use phone number in your office.
Yeah, just down the hall to the left. I'll be walking there in a second. What's up? It's not a lot of lines of code. Yeah, it's probably between 2 and 8, 2 and 10, depending on something like that. Yeah, just depends on how you approach it. Right now, since